Hey, this is the introduction video for Module 2 in the Math 85 online class. So in Module 1, we wrote an expression that expressed our cell phone bill. If you remember, it was charging us $50 plus 10 cents for every minute that we go over our limit. But we don't know how many minutes we're going to go over our limit, so it's 10 cents times this value that's going to change, and we call that value x, and that represents the number of minutes that we go over. So that's our expression that expresses our cell phone bill. And in Module 1, this expression really only had two operations that are happening to x. So if you look at x here, the number of minutes, it's first being multiplied by 10 cents. So we got multiplication. And then it's being added by 50. So the two operations are the fundamental operations, multiplication, and I guess we could have divided it as well. And addition has an opposite as well, which is subtraction. And these four basic operations, multiplication, division, addition, and subtraction, can be performed or can have the operation on the variable x, and the graph of this expression, when we plug in lots of different values of x and see the resulting output value of y, it's going to be linear because it only uses these four basic operations. Now, what I want you to do is I want you to think about this expression. In this expression, there's lots of different operations that are happening. We got multiplication that's happening, I guess, right here and right here. We got addition, we got subtraction, but there's something else that's happening. We got multiplication, we got addition, we got subtraction, but the key to this is there's an exponent that's happening to the variable. So we have this exponent of 2 that's being applied to the variable x. And what this does is it makes this expression have a graph. If we graphed the equation y equals 2x squared plus 2x minus 12, if we were to graph this, the graph actually would be nonlinear. It would look something like this graph. You can see that that's not a straight line. So what that means is that we're coming to a place where we're starting to look at different types of equations that give us different types of graphs, and in large part it's due to these exponents. So one of the interesting things that is true about exponents is exponents makes it more difficult to collect like terms. So maybe if we start at the bottom here, you can see that these two terms cannot add together because they have different exponents. We can't add those two together. An exponent 3 and the exponent 2 make those two terms unlike, and neither one of those two could add to the third term, and of course you can't add to the fourth term because they don't have the same exponent. So the result is that we have an expression with four terms. 1, 2, 3, 4 term expression. And above that we have something with a 3-term expression, and 3-term expressions are called trinomials. Something that has four terms doesn't have a fancy name because they don't happen that often. But if you have 3 terms, that's rather common. It's called a trinomial because neither one of these 3 terms can add together. 1, 2, 3 terms cannot add together because of the exponent. And this guy has 2 terms, so it's called a binomial. Kind of like a bicycle has 2 wheels, a binomial has 2 terms that can't add together. And this guy only has 1 term. He's called a monomial. And there's no reason why we should stop at 4 terms. We could have many terms. So there's a possibility that we could have many terms. The title of this module is called Polynomials. The word polynomial, literally means many terms. So the prefix poly, many, nomial refers to how many values you're adding or subtracting together. So polynomials translated is you could have many terms. And we saw that there was many terms in this example. There was 4 terms, and there's no reason to stop there. I could have 5 terms if I went 7x to the 4th, and then something x to the 3rd, x to the 2nd, x, and then a constant would have 5 terms. But so we have polynomials, which might have many terms, and they'll include addition, subtraction, multiplication, addition, subtraction, multiplication, division, but it will also include the operation of exponents. And that's what's going to make the fact that we might have many terms, because they can't add or subtract together because of these exponents aren't the same. So that's what makes it a polynomial, and we might have many terms because the exponents. So there's a few things that we're going to have to be able to do in this module, and one of the things that you're going to have to do is you're going to have to be able to factor polynomials. And what factoring does is it takes a single polynomial. I think we saw the polynomial 2x squared plus 2x minus 12. And what factoring asks us to do is to create factors or to create multiplication. So one of the ways you can create multiplication is if there is a factor that divides evenly into every term, like in this case 2 divides into all 3 terms, and you can take that number that divides in all 3 terms and use it as a factor on the outside of another trinomial. And that other trinomial is found by dividing that number that's divisible into all 3 terms. So after you divide, the 2's divide off and you're left with x squared. The 2 divides off the second term, you're left with x. And the 2 divides off here and you're left with a minus 6. And then perhaps you need to factor some more. Like in this case, this trinomial can factor into 2 binomials. We can create more multiplication where the x squared splits into x and x. And then the other terms come from values that multiply to give me negative 6, but add to positive 1. See that positive 1 right there? They have to add to that positive 1x. How do you do that? It's a positive 3 times a negative 2. They multiply to negative 6 and they add to positive 1. So that creates the factorization. That creates the factors. Well, that's useful because that allows us to be able to solve some polynomial equations, because what we know about factors is that factors have a useful property if the equation is equal to 0. Think about numbers that multiply. I don't care what it is. We'll call it a times b. If a times b equals 0, then that's useful, because if 2 numbers multiply to give you 0, then one of them has to be 0. If a times b equals 0, then a has to be 0, or b has to be 0. So we can use this useful property when solving equations. So remember our nonlinear polynomial equation. I think I can do a little bit better there actually. Remember our nonlinear trinomial? Now it's an equal sign. See the equals? There it is, equals. Now whenever we have a nonlinear polynomial that's in equation format, we need to get this guy equal to 0. So it's equal to 0, and that is useful so that we can create factors. Remember how we created factors is first we did a greatest common factor, or a GCF. We did that in the previous slide, and then we factored the trinomial into 2 binomials. You guys will learn how to do this in the exercises. And we learned how these factors, If the factors equal 0, remember what we said? If any value multiplies, well, we got 3 factors, and they're all multiplying, and they equal 0, then what has to be true is that one of them has to be 0. Either 2 equals 0. Well, 2 doesn't equal 0. That's nonsense. I'll just X it out and forget about it. Or the second factor equals 0. Oh, that's cool because I know how to solve this equation. This is linear. So what factoring did is it took something that's nonlinear that we started up with, see the star there, and it created factors, and the factors are linear. And I know how to solve that linear factor. I just subtract 3 on both sides. So x could equal -3. See how useful factoring is? Or the third factor could equal 0. So the first factor wasn't useful. The second factor gave me a nice solution. X could equal -3. And by factoring, I could find yet another solution. I can solve this as well because this is also linear. Just add 2 to both sides. X could be 0 plus 2 is 2. So factoring was very useful. So now we're starting to get a little bit more involved because we're not just talking about things that are linear. We're talking about things that are nonlinear because they have these exponents. So we have to learn different techniques like factoring and other things that we need to learn about exponents, because exponents are very important in helping us deal with polynomials, which is really going to be the foundation for the rest of this class and the rest of your studies in college algebra and in a lot of ways statistics and calculus, definitely if you go to a calculus class. Alright, so good luck on your second module.